Hi, everyone. Welcome to the data visualization and image processing track. Today we'll be having Jean-Luc Stevens, Philip Rudiger, John Mees, and James A. Bednar presenting Needles in the Haystack, Easy Interactive Dashboards Allowing Single Point Selection in Billion Row Datasets. There'll be about 5 to 10 minutes of Q&A at the end, so make sure to use the Q&A section if you have any questions. I'll let you take it away.
Okay, thank you. So as you just heard, the title of this talk is Needles in the Haystack, Easy Interactive Dashboards Allowing Single Point Selection in Billion Row Datasets. So from that, you can infer that I'm going to be talking about large datasets, millions and billions of rows. And of course, nowadays, that's not uncommon. You can easily find public datasets with a million rows or billion rows. This is just quite common. There's a lot of public data nowadays, and there's a lot of good sort of data science or science you can do with that kind of data. So while the data is available, getting insight from the data is more difficult. We still need good tools to be able to process all that data, and especially good visualization tools, because that's how you get intuitions for what's going on. Most plotting tools aren't really designed for super large data sets. You normally aggregate, you do like a histogram, or you do some statistics, and then you put it in a scientific paper or something like this. But normally, if you take a plotting tool and you throw your entire data set, gigabytes of it, at your tool, it doesn't normally work very well. So what we're going to talk about is visualizing an entire data set. So what does that mean? It means that on your screen, the visualization, every single sample in your data set has some contribution to what you're looking at. There's something there. It might be a tiny imperceptible change of a pixel value or something, but every single sample is being visualized. So we'll be talking about two problems with this kind of large data, which is overplotting and expressing dynamic ranges or large dynamic ranges. But I won't talk about what that means right now, just show you when I get to what those points actually mean. So I hope a lot of people are familiar with Datashader. It's a project that's been around since 2016. It was aimed to address exactly this. How can you visualize huge gigabyte-sized data sets meaningfully? This project uses Number for speed. It's all written in Python with Number, and it goes through your whole data frame or your whole data set and creates an image out of it. So if you go to datashader.org, you'll see some nice pictures. I encourage you to go to the website. Here we have a nice picture, I should have maybe zoomed in a bit, of the United States. Oops, that doesn't actually help. Where we have a census data set. So this is the census. This is hundreds of millions of points, because that's the sort of size of the population. And you can see the whole structure. You can see the outline of the United States. You can see the whole way people are distributed across the country. Note that, for example, New York is a super dense place. Lots and lots of people in a very small area. But you can still see everything. You still see the sort of sparse areas and the less populated areas. And I'll talk about that in a second. So here's New York again. This time it's done with a categorical color map. There's different colors for the different racial categories in the census. And again, this is the sort of thing that Datashader can do. So Datashader can actually visualize giant data sets, all your data. Every single census result contributes a tiny bit to every pixel of this image. And that's an important point. You really are looking at the whole data set here, and you're seeing the patterns of the whole data set. Now, again, I mentioned that New York is a super dense area, but you can still see the sparse areas, and that's because of this dynamic range issue I talked about. This is not a linear color map. You wouldn't be able to see anything on a linear color map. It's not a log color map either. You still wouldn't be able to see much on a log color map. What we're doing is a type of color mapping that can which actually is aware of the distribution of your data itself. Whatever it is, it'll be able to adapt and change the way the color map works so that you can actually use a full color bar and actually see the structure of the whole data, regardless of how it's distributed. So that's to do with this large dynamic range issue, because you always have data where there's outliers, or you have very dense parts of your data, and so on and so forth. The overplotting issue I'll show you in a second, but essentially Datashader is a rasterizer. That just means it takes all the data and outputs an image. It doesn't try and do axes and little circles for every little point and things like this. It's a rasterizer. So I'll illustrate this by loading a data set. This is a public data set. It's taken off the coast of Belgium. It's about herring gulls, which have little bracelets, GPS trackers, and they're tracking these gulls and how they move around. This data set started in 2013, but the data we'll be looking at is 2018. So I've loaded it with Parquet. We've got some data here. You can see there's 2.4 million samples, which isn't a lot for Datashader, but that's a huge amount for your interactive plotting library like a Bokeh or Plotly, something that went in the browser. If you can stick 2.5 million points, you might have trouble. Of course, this is a data frame with different columns. You have latitude, longitude, the GPS pings, as well as other information like temperature and heading, height above mean sea level. Lots of really interesting data. I only picked a few of them. There's actually a lot more columns, but I just picked a few to illustrate. So as I said, Datashader started in 2016, and this was what you could do back then, and this is the same API as was invented back then. You basically say that you want to do this histogram equalization, which is how you analyze the distribution of the data to get the color mapping right. As I said, it's very important to be able to use the full dynamic range of your color map efficiently. So this is what you get. It is just an image. It's just an RGB image, and you can't really do that much with it, but you can actually see the whole data, and you can see the shape of everything that's going on here. You are actually able to see the distribution of these flight paths. So this is illustrating some features of Datashader, which is that we are looking at the whole data set. No overplotting. This is actually showing the real distribution, and I'll show you what overplotting looks like, and it's quite horrible in comparison. And we are using the full dynamic range of this color bar. So as I said, it's just an image. It's a little bit limited. You can see patterns, but that's not the same as insight. If you want insight, you need to be able to query your data and ask questions and find out what exact data point is this, and what are these data points, and look at different parts, zoom, pan, and do all sorts of things that actually you've got to dive into the data and interact with it and really understand what these patterns are, so just spotting them from a distance. So let's just look at a bokeh plot as a reference. What can bokeh do if you have a small subset of the data? So now I have 12,000 points instead of the 2.5 million. What could you do with it? So this is a fair number of points. Bokeh can handle this just fine. But now we can start doing some useful things, which we couldn't do in the first plot. We can put some context. This is just a white background. There's nothing to see here. But we can put the coastline back in with a tile source in the background. Then we can pan. That's important. You want to be able to move around your data. Again, it's a little slow because there's quite a few points. And then you can do a zoom. You can zoom into your data. That's also important, so you can find areas of interest. Just get in there. And then you can actually start hovering on the data. So there's a single sample. This is just one single sample. Let's just zoom in here. A single sample. I hover on this data, and this is just one row of my data frame. And I can do all the different values, the temperature, the heading, the height above mean sea level, everything, right? So I can actually not just see the whole data set, but I can actually query individual data points from my raw data, the original data source out of the whole data set. I mentioned overplotting a few times, and this is what it looks like. You can't see the distribution here. You just see a mass of blue. Here you can see the structure, but here you just see a mass of blue, and that's what overplotting is. It's the problem when you're using large data sets. So this is using bokeh to show you what you can do with interactive plotting, but only for small data sets. Then you have the panning, which is fantastic, and the zooming, and the background tiles, and the ability to hover on single data points and see the values, the exact values of that real data that you had. But this is not for the whole data set now. It's a tiny fraction. It's 0.005%, as a fraction of my whole data. So what we want to do is have the same functionality, but for the whole data. So in 2017, Holoviews integrated with Datashader, which is very fast, to be able to give you interactive plotting support, or some of it. And the way it does it, it uses a stream system, which lets you do custom interactivity and all sorts of things. And it also integrates the bokeh event system. And what we did is we added things called operations to Holoviews, which made this stuff available. And I'll show you now. In 2018, we took the Holoviews API and we put a wrap on top of it to something that's more familiar with people, which is called HVplot. And if you were at the tutorial on Monday, you'll have seen this. This is just a way of making a bokeh plot effectively. But this time, we have something called Datashader equals true. There's a little switch, and it tells Datashader, it says use Datashader and use this histogram equalization color mapping, and then display it. So now what we have is something much more useful. You can zoom in, and you can see it interactively updates. You can pan around. You can do all sorts of stuff. You can really see your data. And so you have all these nice functionalities, but you have lost some things. There's no color bar here, and there's no inspection. So I can't hover and see what a single point is, what the real data is. It's all aggregated. And it's all these colors, but I can't really get into my data the way I really want to. And the reason for that is that Datashader is doing this color mapping on the server, and an RGB image is being pushed to the browser. And once you have an RGB image, that's not something that can be interpreted in the same way as the real data, where you can put color bar, change the color map, and so on and so forth. So that's why you can't get a color bar, and that's why you don't inspect. But that's not the only thing you can do. So datasheet equals true. You can also use instead rasterize equals true. And then this time it says datasheet, it tells datasheet to just push the values and let the color mapping be on the client side. And if you do that, yes, you can get a color bar. The cost of this, until recently, is that you couldn't use EQ-hist color mapping. You could use linear or log. This is log, which isn't great, and linear, which is absolutely awful. You can see a tiny few little hotspots, but basically you've lost all the structure of your data. So we have the color bar, but we've lost our dynamic range, so it's harder to see the patterns of the data now. You can sort of inspect the data, and I'll actually zoom in and show you. But it's not quite the inspection we asked for. You can get to single point, but what you're looking at now is the output of Datashader, and what that's telling you is how many seagull locations or GPS pings are there in that pixel, but it's not going back to the original data frame and telling you things about the temperature and the height above sea level and so on. You've lost all that really important context about that single point. You've lost it because you're now looking at an image that has been rasterized, and all that information has been lost. And all you get now is how many of these samples fall into a pixel. Okay, so we've got the color bar back, but we still don't really have inspection, and we don't. And that's what I mean by inspection. It's really getting into the data and actually finding a single sample and identifying that thing in the raw data that you can go back to, and then really identify it to the data that you started with in this whole huge data set. So that was the state until 2017, 2018 for htplot. But now let's talk about what's new in 2021. Bokeh now has client-side histogram equalization color mapping, which means we can now see the same sort of thing that we could see before with all the structure and all the dynamic range that we want. We can zoom in, we can get down to individual points, and we can pan around, and it's really quite nice. So this is new. This is a real big improvement in being able to use Datashader in an interactive way. But we still have the same issue with the inspection. We still don't get back to the exact row of a data frame for a single sample. So we're getting very close now. We just have this one inspection link. What else is new this year? With help from Matplotlib devs, there's a new artist, a custom artist that allows interactive usage of Datashader with Matplotlib. So this gives you the panning and the zooming and so on, which is great. And of course, I'm not showing you a full example of Matplotlib. You could add the color bar and the map and make a nice Matplotlib plot, and then maybe use it for publication and so on and so forth. So, and the final thing that's new, and the title of the talk, is about inspecting those individual samples. It's just about getting this last cross ticked. So here, we have to think about what we're trying to do. You have a cursor on your screen, and what you want to do is find the sample that's under your cursor and give information about that sample. You've got a rasterized display, the output of Datashader. Now you need to go back to the original data frame and get that row, get that information, and show it. So what you can do, especially with Holoviews, because Holoviews has the whole pipeline, you can work backwards from this output image from Datashader back to the input data frame. And what you can do then is do a filter around the cursor location, the little area, and find the closest sample to your cursor, at which point you only have one point to show with Bokeh. And that one point can have all the hover information that you want about that row of the data frame. So I'll illustrate by first making a little Holoviews tile source. This will all work with htplot in the future. We're working on that. There's a few wrinkles, but I also think it's helpful to illustrate it with Holoviews here. Then what you can do is you can just make the same plot we just saw. There's nothing new here. There's no inspection yet. All I've done is use the Holoviews API to get the same plot. But notice that this is our data frame in this points object, which wraps it, and which means that Holoviews knows about this data frame and can actually get back to the raw data. Right. So now we have our EQ-hist enabled and so on. And now the new thing is an inspect tool. And this is what we've been trying to work towards. What it does now, if I zoom in, I get a little white circle. That little white circle is a bokeh point. That little bokeh point has the information of that sample that the circle corresponds to, that latitude and longitude. Which means that now we find patterns, we can zoom right in, find a single point out of our whole data set, and if we had an ID, we could even find the row, the ILOC or the location of that exact data point out of the 2.5 million samples that we have. So that's kind of ticks off all the boxes. We got all the interactivity we want, and we're working with a full data set. Every single sample in that data set is contributing to that data shaded image in some way. So I did say that I'd be able to give you a dashboard, a whole dashboard. So if you went to the Holoviews tutorial on Monday, you might have learned a bit about panel. It's quite straightforward. What it does, it lets you wrap up things, wrap up all these visualizations, give it a title, give a description, so on. And then you can mark it .servable. And then you can just run panel serve and the name of the notebook, and I've already run that here. And that's what you get. I've made it responsive so it fits the screen and so on. But now you have a full dashboard, 2.5 million points. And as you go in, you can go all the way down to 1 point and find out what it is and what it's doing there. There we go. So I should zoom in a bit more. So there's a point here. Oops, here's a point. So there's that little white circle, and here's the information about it. Like the height above mean sea level, the heading of that bird at that time, and the temperature, 33.9 Celsius. So that's kind of the point of the needle in the haystack, right? One sample out of 2.5 million. I did say that we talk about billions, and you can do billions. So this is just running on my laptop, remember. If you had a more powerful machine, you could even do even more. This is a different example, which is very similar, where instead of tracking birds, we're tracking ships. These are transponder pings. This is AIS data, where ships have different, have records about what type of ship it is, what heading it has, and so on, and also what its GPS coordinates are. And this dashboard is from a data set of 200 million transponder pings. And what you can do, and this is how it initializes, you can actually set up hooks with this mechanism, where you can have a row where you can see that in that little area, the two closest ships are these two. You get a URL to information about the ship, and I set up a hook where you can use an API to actually see a picture of the ship that you're looking at. So let's have another look. So let's try zooming in somewhere. And not every ship has a picture, by the way. So it might take a second for data shader to update. Again, it's a very large data set. I think it probably swapped out of my memory while I was talking. There we go. That's where we were. And if I click somewhere else, you'll see the little white box move, and I can get some other ships. There we go. They don't have any pictures for these ships, but these are the two ships in that box. So again, back to a single AIS ping out of 200 million pings. So yes, it really is able to scale to, oh, there we go, one with the picture, which is nice. There we go. So this is, again, the needle in the haystack that I was talking about. Zoom out, and we can see the whole data for this. This is the western side of the United States that we'll be loading up now. Okay, and there's one last thing I want to talk about, which is I've shown you points. I showed you how to select little like GPS coordinates and things, but there is more you can do. We have polygon support. Okay, this is loading. I might actually close this one now that I'm done with it. Okay, this notebook should load up. Where essentially what we have now is New York City we saw earlier, where it was census data, which was the picture that I showed you from Data Shader, which is a single point. It tells you where. Oh, okay, the browser's is struggling now. I might just close this as well. Okay, if the notebook loads, what will happen is you'll see polygon data. So this is actually going to be the shape of the buildings. I might have another way of loading this, actually. I'll give it a second. Actually, what I might do is just restart this. And essentially, it's not just point glyphs, it's also polygon glyphs. And this is like shape files and so on. Oh dear.
You can just show it on examples.
Yeah, so yeah, that's a good point. I can show you a static version on examples, which is this one, NYC buildings. Here we go, where it's loading. Where here what we're seeing is the building shapes, and then you got them categorized by the type of building, whether it's a school or whatever it is. Oh, now it's opening. And you can zoom in, and again, this is not the live version, and I'll try and show you that in a second. You zoom in, and you can inspect the hover information of a single building So hopefully that will load. It normally takes about 30 seconds to run the notebook. I think that's it. Oh, I should finish with the conclusion, which is, yes, we're still working on it. I talked about polygons and points, but we also want to work with things like paths and lines. We're working on extending it. And as I said, we want to make this work nicely with hrefplots so that anybody can start using this functionality. We also want it to work with link selections, which is something that was talked about in the Holoviews tutorial on Monday, where you can select a plot and do a subselection and see another plot update. Or drill down, where you, again, pick a small amount of the plot and just look at a little portion of the plot. Okay, I think that covers my conclusion. At this point, I guess, any questions?
Just one more point, that you can go to examples.pybiz.org to see the ship traffic example and the NYC building as example. Both of them should let you click on something live to try it out yourself.
Yeah.
Even if it's not running on Jean-Luc's machine, it should run on yours. I
think just my browser struggling here with all the data I've been noting. And also, it's a good point because there's actually more in the notebook on PyViz. For ship tracking, you can actually see more of the ship data across the whole US. It's really quite pretty. Okay, it's a shame about this, but yeah, that's just my browser struggling.
Okay. So there's a question: is this notebook available online to access?
The one I've just done, it will be. It isn't yet, but as Jim mentioned, and I just mentioned, these examples or related examples are on examples.pyviz. Okay, so it's loading. So here we go. This is what I was saying. This is bigger portions of the data. This is the whole United States. This is the whole of the US. You can actually see the coastline of the US highlighted by the ship tracks in this AIS data. It's all very pretty, and these are certain parts of the US, the Gulf Coast, for example.
So to answer that question, there's already a gull tracking example on examples.pybiz, and it can be now updated to include this information. So you should see it on examples.pybiz.org. And then someone else has a question: is it possible to automatically circle the nearest neighbor pixel to the mouse rather than having to hit the pixel?
That's a good point. So you don't actually have to hit the pixel. There's actually a pixels argument in the inspect, and that's the window, this delta window around your cursor position. And then it takes the nearest in that window. So you don't actually have to hit it exactly, because that would be a nightmare if you actually had to hit a tiny little pixel. And you have so you have an adjustable window size. And one thing I didn't show is that you can actually show that window. Part of the operation will show you the size of the search area in which you're picking the closest. And there's other features that I haven't talked about, like you can show the n closest, you can show the 3 closest, or the 5 closest samples in that window. So yeah, that's a very good question, and it's something we have thought about.
Yep. Any last questions?
I'm just disappointed that this isn't loading. I can try. I'll try loading the one on the website, on the deployment.
All right.
Was there another question? Any more questions?
I see.
Sorry. If you have any questions, you can post it in the Q&A section or raise your hand to be brought on stage. If anyone has any questions. If not, I have a question. I was impressed with how like responsive everything was, considering you're querying like something in like really giant arrays. How did you achieve that?
Okay, so actually something we've just optimized recently. The way it is, it's actually, the naive thing is to do a simple filter on a data frame. So this one's actually working. So a simple filter on a data frame, which would be something like between this latitude and this longitude, between this between this range of latitudes and this range of longitudes, and then you get your simple filter with like a normal pandas kind of query, a mask type indexing query, and then you can then do the search. But we've actually optimized that, so we actually need 2 passes, one for X dimension, one for Y dimension. So we're doing 4, because normally you do less than this longitude, then greater than that longitude, and then same for latitude. We got it. Yes, great. Sorry I couldn't get it working on my own machine. I think there's a lot of data that I've been loading up. So this is the New York polygon.
To finish the answer to the question,
yes,
though, there's a spatial index in the ship data traffic example that reduces the number of data points you have to search to a smaller spatial local region. It's optional. It doesn't require a spatial index, but certainly if you have one, it'll be a lot faster.
So here we go. There we go. This is what I wanted to show you. This is New York City, and now you can hover over a single school. You can see the shape of that school here, and you can find out what it is. Oh, and to expand on Jim's point just now about the indexing, there's several tricks that can be used when you have a really huge data set, and these are all optional things that act as optimizations. One of the things is you can use Dask, and then you can partition your data spatially. So if you're looking at one part of the world, you don't need to load the Dask data frame for the other side of the world, right? It's all spatially localized. That's part of the optimization you can do, is just load the amount of Dask data frames that you actually need and make it a small number, a small subset. And then also you can do that sort of spatial indexing that Jim was talking about. There we go. Okay, any more questions? What's this?
What spatial indexing scheme do you use is a question, and we're using spatial pandas at the moment for this, which uses a Hilbert curve way of indexing two-dimensional space with a one-dimensional index value, and it largely preserves spatial locality. There's no way to preserve it perfectly, but it's basically draws a line over the entire 2D shape, and then that your position along that line determines whether you're contiguous in the array.
Right. Though I'll note that the girls example didn't use any special acceleration at all. That's just for the AIS data set example.
That's right. So a couple million points, no problem. A couple 100 million points, it's helpful. It's not required, though. It's maybe a 2 times speed up in our examples. Eventually, it will definitely be necessary because a data set could be infinitely large.
I'll also notice that the sort of thing you can find out when you explore data this way is things like, that's a church. That little line at the end of this building is marked as a church. It's a quite interesting shape for a church, I have to say.
I bet it's a tax dodge.
It's the Grace Garden Presbyterian Church, apparently.
Okay, it'd be a real church.
So yeah, I think that's it. Yeah, we do want to support more types of glyph. We do want it to work with htplot. This is all very exciting stuff. And I did say in the talk that this has been released in Holoviews. The only thing is we are still working on it a little bit. We still want to improve our integration, and we might have a very small API changes, but we're still thinking about it. We're still
right.
iterating.
It's in the current release if you download the current release of Holoviews, but it'll be improving over the next few months.
Okay. Any last questions?
The question is, does it require a data frame, or can it also work with X-array style information?
Right now, it's based on data frames. Jim, you're probably in a better position to answer that.
I can answer it. Right now, you don't need X-array. You don't need it if you have X-array, because X-array is already regularly gridded, which gives you instant spatial indexing effectively, so that you can just, once you've got your plot on screen, you can just read off from your cursor position exactly which element of which data set to go to. You can just look it up directly. Here, you had to do the search. This one's, the data frame's the hard case. The X-array case already worked well.
Okay. Okay.
Okay. Yeah, I just wanted to note that we're at time. Thank you for presenting. It was super cool. And we'll have our next session in about 5 minutes.
Thank you very much.
Thank you. Thanks for moderating.